Work a few examples so you guys can get the hang of it. Let's look at these molecules here. And remember, the first step that we have to do is to identify the longest continuous chain of carbons. And in both of these molecules, that longest continuous chain is 4 carbons long. So each of these would be a butane. But for 4, ANE for fully saturated. No double or triple bonds. I also have 2 methyl groups on each of these butanes, but in each of these different molecules, the methyl groups are in different positions. So I want to name my substituents, and I have 2 methyls, so I'm going to call this dimethyl butane. Now I need to tell you where those methyl groups are located, and I do that by numbering the carbon atoms. In the first case, it doesn't matter which direction I start numbering from, because I will have a methyl group at carbon 2 whether I start numbering from the left or I start numbering from the right. My methyl groups will be at 2 and 3. So my first molecule is 2,3-dimethylbutane. In my second molecule, it does matter which direction I start numbering from. I have to start numbering from the right, because that puts the 2 methyl groups at carbon 2. If I started numbering from the left, my 2 methyl groups would be at carbon 3. So this molecule is 2,2-dimethylbutane. There is no such molecule as 3,3-dimethylbutane. That would be incorrect. So here's a pretty complicated molecule, and let's try to go ahead and name this. Now remember that our first step is to identify the longest continuous chain of carbons. So my longest chain of carbons has 7 carbons in a row. I could also call this my longest chain. It doesn't really matter, because at the second carbon from the left or the right, I have a 1 carbon branch. So if I count up the carbons that I've indicated here, that I've circled here, I will also come up with 7 carbons. So it doesn't really matter. I could do it either way. Now I need to number my carbons, and I need to number them in such a way that I start closest at the end, closest to the first substituent. Well, that's kind of funny, because either direction that I start numbering from in this example, I would have a methyl group at carbon 2. So starting from the end closest to the first carbon atom that has an alkyl group or other group, but I have a methyl group at the second carbon either direction. So I've taken this from the rules for nomenclature from the UPAC website. When series of locants containing the same number of terms are compared one at a time, the series is lowest, which contains the lowest number on the occasion of the first difference. So what exactly does that mean? That sounds pretty complicated. But if I numbered in the opposite direction, right, my locants would it be at 2, 4, 5, and 6. And I compare that to 2, 3, 4, and 6. So since the first point of difference is 3 versus 4, right, I go with the lowest number. So the order that I number my carbons is starting from the right, which gives me my locants at positions 2, 3, 4, and 6. Now, I have a 7 carbon chain, so this is going to be a heptane. I have 4 methyl groups attached, so it's going to be tetramethyl heptane. And in front of that name, I'm going to put my locants. So there we go, 2, 3, 4, 6, tetramethyl heptane. It sounds pretty complicated, but I think that it's pretty straightforward, and you should be able to get the hang of this pretty quickly. All right, so let's look at another example. And again, I want to identify my longest chain of continuous carbons. And you have to be very careful to choose the longest chain. All right, it doesn't necessarily have to be the carbons that are all in a line. You don't number this set of carbons, all right, because that would give you only 5 carbons, what I'm showing in this box. You number in the direction that I've shown here. So we have 6 carbons in a row, so this will be a hexane. I have a 1 carbon branch or a methyl group at the 3 position. Remember that I start numbering at the end closest to the substituent. So this would be 3-methyl hexane. This is a little bit of a complicated example that includes a halogen. We have a chloro group or a chlorine attached to this alkane, but I'll just go through this and just mention that you treat halogens pretty much the same way that you would treat an alkyl substituent, and that's what we're talking about, these alkyl substituents. What I mean by that is a substituent that's basically a hydrocarbon substituent. Again, we're going to identify the longest continuous chain, and we're going to number that chain starting from the end closest to the first substituent. As my substituents, I have 2 methyl groups, I have a chloro group, and I have an ethyl group. So I want to put those substituents in alphabetical order. Chloro comes first, followed by ethyl, followed by methyl. And I also want to point out to you that we do not alphabetize the di, tri, tetra, and so on. We alphabetize this according to the M for methyl, not D for di. So this molecule is 3-chloro, 4-ethyl, 2,4-dimethyl octane. Here's another example, and in this example we have 2 different kinds of substituents. Again, we've got an ethyl and a methyl. Let's identify our longest chain, and here it is, and now I've switched over to using the skeletal structure, but you should be able to count the carbons and figure out how many carbons we have. It looks like we have 1, 2, 3, 4, 5, 6, 7, 8. So this would be an octane. And let's think about how we want to number this. I could number starting from the right, and my substituents would be at carbons 4 and 5. Or I could number starting from the left, and again my substituents would be at 4 and 5. So that's a little bit complicated, deciding if the methyl should be 4 or if the methyl should be 5. And again, I've taken this statement directly from the UPAC Rules of Nomenclature, which says that if 2 or more side chains are in equivalent positions, and these 2 would be in equivalent positions, 4 and 5, according to how you would number it, which direction you number from, the one that's assigned the lower number is the one that's cited first in the name. And remember that in the name, we cite the substituents in alphabetical order. So ethyl takes precedence over methyl. So the ethyl group gets to be at 4. The methyl group gets to be at 5. So this compound would be called 4-ethyl, 5-methyl octane. I would not call it 5-ethyl, 4-methyl octane. That would be wrong. We've been starting from the structure and then figuring out what the name is. Let's see if we can go in the other direction and determine the structure when given the name. And this is actually a lot easier than figuring out what the name is. So in our first example, we see we have a pentane. You want to look at the root, which is pent. Our suffix is ane, so obviously no double or triple bonds. And we have an ethyl group, so that's a 2-carbon group attached to our 5-carbon parent chain, and it is going to be attached at the 3 position. So here's my 5-carbon chain, there's my pentane. If I number my carbons, I have 1 through 5, and I'm going to put a 2-carbon substituent, or an ethyl group, at carbon 3. So there you have 3-ethyl pentane. What about the next one? Well, again, it's a pentane, so that's going to be 5 carbons. I have trimethyl, so I have 3 methyl groups, or 3 1-carbon substituents on this molecule. Let's go ahead and number our carbons. My methyl groups are going to be at 2, 2, and 4. So 2 methyl groups at carbon 2, 1 methyl group at carbon 4. So there you have it.